everyone, ciao. Thank you so much for staying to the end of the day. So we're going to be talking, of course, about generative AI, and a lot of us have been working with Gen AI for probably about a couple of years or more even. But you might have wondered about the limitations that exist within generative AI, or you might have come up against them as well. So I'm talking about things like referencing dynamic data sets instead of just referencing static data. What about interacting with APIs, so interacting with different parts of your existing systems? Multi-step reasoning, you can get it to do some of that by itself, but what about real complex multi-step reasoning? So basically anything that takes you beyond the basics of Q&A, text summarization, or helping you to write an email to your boss. So like me, you might have wondered, what if I want to actually create applications that are able to interact with other systems? Retrieve the latest information instead of stale information that's stored in S3 and been ingested into some vector database? Or execute tasks and trigger complex workflows? Well, if you've ever wondered about that, then you need to know about agents. And this is one of the #1 skills to know for 2025 and beyond. I work for a training company, of course, and we do a lot of research and asking our customers about the kind of technologies they need to learn about. And agentic AI comes up in the top 3. So my name's Faye Ellis. If you haven't met me or seen me before, I'm a principal training architect at Pluralsight, a training company. Recently made an AWS Community Hero, so very exciting for me still. That only happened very recently. I'm passionate about all things cloud. I've worked in IT for longer than I want to say, to be honest. Worked in lots of different roles, most recently as an architect before I became a trainer. So I worked as a sysadmin in DevOps teams as well. Based in the UK, and if you want to talk to me about something other than cloud, you can talk to me about bread, because I'm obsessed with making my own bread. So we are here to talk about generative AI applications that can execute tasks using specifically agents for Amazon Bedrock, a recently released feature. We'll talk a little bit about what is Bedrock. I think probably most people here already know. We'll talk about agents for Amazon Bedrock, a little bit about Python, the AWS SDK for Python, it's called Boto 3. We'll talk about Jupyter Notebooks. If you've not used them before, you're going to love them. You are going to meet my best friend, Mia Amicha, Miss White. You're going to meet her. She's the inspiration for a little application that I created. We're going to review the architecture of my app. I've got a demo to show you. It's about 10 minutes long. And if you want to try it for yourself, you can do using my resources, which I'm going to share with you, so you can try and build this yourself and update it, make it better, change it around for your own use case. And we might have time for Q&A as well. So what is Bedrock? Who has already been using Bedrock? Show of hands. Loads of you. Okay, so you know that it's an API endpoint that gives you access to loads of different foundation models, all hosted in AWS. So pre-trained large language models that allow you to build Gen AI applications. You get access to a wide variety of different models. They're adding new ones all the time, so you can select the best one for your use case. It's serverless. Sorry, I need to take a drink. It's serverless, meaning there's no infrastructure needed to manage it, and you can get up and running really, really quickly, which also reduces the operational heavy lifting, of course, as with anything that we use which is serverless. Accelerating your time to market. If you've got that billion-dollar idea, you can start very, very easily, very quickly, and get up and running with an easy prototype. So you get a selection of models. They've provided loads of different models from industry leaders so that you can select the best one according to your priorities and according to your requirements. For instance, if you want the most cost-effective models, the most affordable models, maybe you want to have a compact model that's going to perform well for simple queries, but also have very low latency. Maybe you want that balance between price and performance. Or maybe you're looking for something that's really high performance for really complex tasks and you don't really care how much you're going to spend on it. So they've got something for everybody and more being added all the time. Now, agents for Amazon Bedrock, this big buzzword, agents, that's going around like the last kind of 3 to 4 months. So these are components that are really able to analyze a more complex task at hand and break it down using the kind of logical reasoning capabilities that are built into the pre-trained AI models. So they can break down a larger task into kind of a logical sequence of smaller steps, perform the API calls that are necessary to actually take action, so to execute actions on your behalf. And that's what I mean about going beyond that simple Q&A or creating some text, actually doing something for you. And also interacting with you as well, so coming back and asking the requester to provide clarification if necessary, provide more data if necessary, or seeking to actually find additional data using the resources that it has available to it. So maybe using API calls to interrogate different systems, or have a look in different databases and collect the data needed to actually fulfill the request. I've got some example use cases for you. What about a customer support application that's able to automatically, all by itself, process refunds and exchanges when you receive a faulty product? What about an HR system that automatically processes your leave or your time off vacation requests? I had to remind my boss earlier, like literally 30 minutes ago, that I'm going on holiday next week and she hasn't approved my request yet, even though I'm entitled to take that vacation. It would be great if the bot just did it for me and I didn't have to like poke my boss when she's busy. What about an expenses system that automatically reimburses you and approves business expenses, especially out-of-pocket expenses? You know, I'm traveling at the moment, I'm having to use my own credit card to pay for taxi cabs, etc. Wouldn't it be great if there was a system that would approve those expenses and reimburse that money back to my bank account before I even got home? And finally, a healthcare application that's able to approve repeat prescriptions of regular medication that your doctor has said that you can take. And instead of having to bother the office, phone up the surgery and ask for a repeat prescription to be processed, actually allowing you to do that yourself using a little chat application. Sorry, I'm recovering from a cold, so I'm more dry than usual. Okay, so Agents for Amazon Bedrock is all about combining generative AI with real-world execution. So really giving you dynamic interactions instead of interacting with kind of static data. Giving you that element of automation, so being able to do things for you instead of just creating text. Giving you transparency as well, so being able to actually explain how did it get to where the conclusions it got to, and how did it find that information, and how did it actually use its reasoning capabilities to get there. And also that ability to create domain-specific applications, because that's really going to be the differentiator for all of us. We're not going to make money, our companies are not going to make money just leveraging AI out of the box. We need to make it domain-specific so that it's really solving the problems that our customers have. Okay, so let's talk a little bit about the technology I used to create my little baby application. First of all, I used the AWS SDK for Python. It's called Boto 3. Has anyone used that particular SDK? Yep, loads of you, okay. So this enables our Python code to actually interact with AWS services. So it's kind of like a wrapper to some of the APIs that we interact with when we create or interact with AWS services. Specifically, in this case, we're interacting with Bedrock. But when you see my code in action, you'll see that I actually used this SDK to create some of the prerequisite things that I needed. Jupyter Notebooks. Has anyone used Jupyter Notebooks? They're brilliant. They're so fun. If you've used them before, then I'm sure you love them. If you haven't used them before, I think you're going to love them. The way they've been implemented within SageMaker is that they're a browser-based IDE. So they allow you to write your code, debug it, do troubleshooting, even build AWS components. And you can run the code kind of cell by cell. Instead of running an entire Python script in one go and then having to debug it, you can run each element of your code cell by cell. So you can really easily see what's gone wrong, what do I need to change, what do I need to rerun, etc. And you'll see it in action in a moment. One of the things you can do with Jupyter Notebooks is you can create these interactive documents. And these are document files that actually contain your code. And they can also be including your comments, your commentary, any data visualizations. For instance, using libraries like matplotlib, if you've got data that you actually want to investigate and you want to create visualizations, you can do that within the Jupyter Notebook as well while you're working. So these really allow you to run your code, experiment, and create and kind of document and create comments around the code. And you can actually share these documents so somebody else can then run your code and get the same experience if they've got the same setup as you. And it's this Jupyter Notebook and an interactive Python file that I'm going to be sharing with you later. So you can take that away and you can run all the commands yourself and see this in action for yourself. My best friend, Anna White. This is my best friend, Anna. She's a teacher. And she's a really busy teacher at one of our local schools. Now, Parents' Evening is happening really, really soon. And if you have kids of school age, you'll know that that's the time when you get to go and see the teacher, find out what your kids have been doing all year, find out that they're going to fail history if they don't do something about it. So as you can imagine, it's a really busy time for Anna. She gets, excuse me, sorry. She gets loads of different questions, emails, messages coming in from the parents of all the children who are taking her courses. So they ask things like, who's the history teacher? Which room do I go to meet the IT teacher? Oh, and when are you available? Are you available at 6 p.m. or 7 p.m.? She's got all these different questions that she has to give answers to, but she's actually got a full-time job. So she basically needs a system that's going to be responsible for booking some of these appointments with the parents and answering some of the questions that they've got. So this is all about enabling the parents to ask questions about teacher availability, booking a meeting with their child's teacher, and not taking up Anna's time with all these questions. Okay, so I built a little application, my booking assistant application, all in AWS. And it's using agents for Amazon Bedrock to trigger some actions using Lambda, and it's using some data in DynamoDB as well. So it's all serverless. Okay, so in DynamoDB, we've got two tables, one holding information about teachers and what rooms to find them in, and one holding information about appointments. And notice that I'm giving really basic information. I could build out a massive data set if I wanted to do as much work as Linda and create a huge data set. But instead, I've created a real minimal data set because I really wanted to see, what can this thing do? How does it hang together? What if I really limit it in terms of the actual data I give to it? Next, I've got a Lambda function which is able to do a few different things. So check teacher availability, it's able to book appointments, get available slots. Once again, I could build this out and add loads more functionality, but I wanted to get it all working first just to see what it could do. Next, we have Amazon Bedrock, of course, access to all the foundation models. We've got an agent and an action group. And it's this action group that actually defines the capabilities of the agent. So what can the agent actually do? And these actions are going to map into the capabilities that we provide in the Lambda function. So when a question comes in from one of the parents asking, is Miss White available at 1800? The foundation model in Bedrock is invoked, and it's going to look at its action group and its agent. What capabilities do I have in order to fulfill this request and answer this question? It then triggers the Lambda function to take a look at the data in our DynamoDB table, receive a response, and then provide that response back to the parent to say, yes, Miss White is available for an appointment. Now, there's lots of other different questions and queries that we can ask this system. We should be able to ask which room to find which teacher, which appointments has Miss White got available. We should be able to book appointments and cancel appointments as well. But I thought it was fun to try and find out, okay, what are the limitations of this application? What can I do? What can't I do? So, sorry. So let's take a look at the code. First of all, I started off by importing required libraries, so things like the AWS SDK for Python, importing JSON. There are some more as well. I've just kind of tried to make it brief on here. We create Boto3 clients for the services that we're going to use. And these are used to send API calls into the AWS services. And because I'm using this Jupyter Notebook IDE environment to actually create some of these resources, I need to create Boto3 clients for those resources I'm going to create. So of course, we always have to create IAM resources. I've also got my Lambda client as well to create my Lambda resources. But the ones to note here are sorry if I'm standing in the way. The ones to note here are the Bedrock agent client, which is used for creating and managing, so configuring our agent, and the runtime client as well. And this one is used when actually interacting with the Bedrock service. So you also always need to create this runtime client in order to start querying Bedrock. Next, we create a Boto3 session. So this is used to handle our session, handle our AWS credentials, allowing us to actually interact with AWS. Next, we're creating some variables which are going to be used when we actually come to create the agent. So we're defining identity and access management policies and role names. The model name here, very easy to update it here. You might find if you change this model, you're going to have to change some of the other parameters as well, the parameters used to actually invoke the model. Here's my agent instruction, and this is provided in natural language, which I think is really interesting, the way that they've implemented this, allowing you to actually describe in natural language how you want your agent to behave. And I've kind of truncated this so it's not taking up the whole page. But these instructions can actually be refined as you go through testing of the application and see, okay, we need to be a little less vague here, we need to be more prescriptive. Maybe when we get feedback from the user, we might want to change the instruction slightly. Here's where we're naming the action group. So that, remember, that's defining all the actions that the agent can take. We need to provide a Lambda execution role, which gives the Lambda function access to do what it needs to do. In this case, it's going to be reading and writing to the DynamoDB tables. And our function name. So these are all the variables that we're going to use in subsequent steps when we actually come to create the agent. The next step in the process is to create our data. So I needed some data to play with. So I created some DynamoDB tables with some dummy data. And I also deployed my Lambda function. I've actually done this using the Jupyter Notebook. But of course, you could do it using CloudFormation. Why not? The next step in the process is actually creating the agent. So this is the way that we're creating the agent. And when we create the agent, we need to provide our name. We need to specify the identity and access management role that's going to be used by the agent, because remember, that's going to be taking action on our behalf as well, like triggering the Lambda function. We provided the name of the AI model that we defined earlier, so the foundation model we defined earlier, and the instruction that we defined earlier as well. At this point, we need to actually define the functions that the agent is going to be able to do. And this is done in a function schema. So each action, this is just an example of one, each action has a name, a description, so in this one is just get the details of an existing booking, and the parameters needed to actually complete that function. So in this case, it will need an appointment ID. So for each of the functions and capabilities of the agent, there's a definition just like this. At this point, we're invoking the agent. So we're first of all setting the parameters that we're going to use for actually invoking the agent. Here's our prompt. So when is Miss White available? Our agent ID that we want to use to actually respond to the prompt. And that's it. Oh, that's it. Sorry, I'll go back one, because that kind of, I thought that there was going to be another point. But yeah, basically that's all we need when we're invoking the agent. So we're setting the parameters for invocation, and the main parameters are, okay, what is the prompt and what is the agent ID? So now we are ready to run the demo. I think I need to just come up here, play, in Sage. In SageMaker AI, I'll select Notebooks and open Jupyter Lab. My GitHub repository is already downloaded to my notebook, and here's my IPYNB file. Now this is an interactive Python notebook that we'll use to develop and test our application. So in this notebook, we're going to create an agent for Amazon Bedrock that interacts with some data held in DynamoDB. And using this agent, parents can check teacher availability for the upcoming parent-teacher meeting and book an available time with a teacher of their choice. And we'll use a Lambda function to check teacher availability and create the bookings. So first, I'll scroll down to the first cell, select the cell, and if you haven't used a Jupyter Notebook before, you can use this icon up here to run the code in the selected cell. So first of all, we're going to update Boto Core, Boto 3, and the AWS CLI packages. So I've selected the cell and I'm going to run the cell. And we can ignore any errors from the pip dependency resolver if they happen to appear. Now when this star symbol is showing here, that means it's processing. And then when a number appears, that means the operation is complete. Moving down to the next cell, we're going to restart the kernel, install the packages and utilities needed for this application. We're using the logging facility for Python to help confirm that things are working as expected. And next, we're going to create the Boto 3 clients that are needed for a number of different AWS services, because we're going to be creating resources using things like identity access management, Lambda, and most importantly, the Bedrock agent and the Bedrock agent runtime. After that, we're setting configuration variables for the session, as well as those needed for the Bedrock agent and a Lambda function that's going to be created later. So we're creating our Boto 3 session,
And then our configuration variables are down here. Now, the particular ones to note are, first of all, here's where we're specifying the foundation model that we're going to use. And this can be easily updated when a new model comes out that you want to try. And then this one, which is the agent instructions. So these are the instructions we're giving to our agent. And we're providing the instructions in natural language. So you're a booking system agent, enabling parents of children attending Fir Tree Lodge High School to book 30-minute appointments with their child's teacher on Parents' Evening. And then in the next step, we're creating the data set. And we create 2 DynamoDB tables to store the data that our agent is going to interact with. So first of all, we've got a teachers table with information about our teachers. And then we've got a parent-teacher appointments table with data relating to the existing bookings. So this code is just going to create and populate these DynamoDB tables so that we've got some data to play with. After that's done, we're ready to create our Lambda function. So we'll use a Lambda function to interact with the data in DynamoDB. It's going to have the ability to check which appointments are available at a given time and date, and book a meeting if no conflicts exist. And this function is going to be triggered by the agent. So first of all, we're going to write the Lambda function code to a local file before packaging it and then deploying the function. So here's the code that's going to be invoked by the Bedrock agent. If we scroll down, we've got the ability to do 3 different things. So first of all, check teacher availability. So check if a teacher is available at a specific time, book an appointment with a teacher, and get all the available appointment slots. So I'm giving this application really basic data and really basic functionality as well. And our agent will need to figure out how to respond to our requests using the data in the DynamoDB table and the functionality that we've provided in the Lambda function. So it's going to use the reasoning capability of the AI model to work out how to process requests. So let's run that cell to create our Lambda code. It's going to appear over here on the left-hand side. So it's just written that code locally. Next, we need to create an IAM role and policy, allowing our function to read and write to DynamoDB. So I'll run that cell. And we can see we're giving it read-only access for the teachers table and read and write for the parent-teacher appointments table. After that, we can now package up our Lambda function to a zip file and deploy our Lambda function. So I'll run that cell. And then the next step is to create our agent. Now to do that, we first need to create the identity and access management resources, so an IAM policy and role, allowing the agent to perform Bedrock model invocation. So I'll select my cell and run it. That's creating our policy. In the next cell, we're creating the IAM role for the agent and attaching the policy. After that, we are ready to create the agent. So we use this create agent function to create the agent, and it requires an agent name, underlying foundation model that we specified earlier, and the instructions that we provided earlier as well. So I'll select that cell and run. We'll store the agent ID in a local variable to use later on. And now we're creating the action group. So this is the action group that uses our Lambda function. And the action group functionality is defined using this function schema. So we need to provide a name for each function, a description, and the parameters for each of the functions that our agent is able to do. So this action group just defines all of the actions that the agent can help our users perform. So we can check teacher availability, book appointments, get available slots, get teacher info, get booking details, list teacher schedule, cancel booking, and get next available slot. And this is all based on the data that we've got in our database. So let's run that cell. And then we can configure and create the action group using the schema that we just defined. So I'll select that cell and run it. After that's done, we need to enable the agent to invoke the Lambda function by adding the required permissions to a resource-based policy. So we're adding Lambda invoke function to the resource-based policy for our agent. Next, we'll prepare the agent by creating a draft version of the agent that can be used for internal testing and extracting the agent alias ID from our response. So when you first create a Bedrock agent, it automatically creates this test alias. It's called TST alias ID, and this alias points to the working draft version of our agent that we just created. And after that's done, we are ready to invoke our agent. First, we'll set up the parameters for the invocation. Here's our prompt. So when is Miss White available? And then in the next cell, we're invoking the Bedrock agent using the parameters that we've defined. And there is our response. Based on the available time slots, Miss White is available in room S3 at the following times. Next, let's try another prompt. Who is the IT teacher? And invoke the model. And here's our answer. So it's saying, I apologize, I don't have the name. The only information I could obtain is that their teacher ID is T003 and they are assigned to room IT2, which likely corresponds to an IT or computer science subject. So it's using the data it has to try and solve the problem, even if it doesn't explicitly find the information in the database. Let's try another one. In which room will I find the history teacher? And it's able to find it. The history teacher will be found in room H1. So I'm giving it really basic data and really basic functionality, and our agent is trying to figure out how to respond to our requests using the data and functionality we've provided. And if you do this exercise yourself, be sure to clean everything up. So I've included the cells that you need to delete everything to avoid any unnecessary charges.
Okay, so that was my little demo. My takeaways for you are that I created a conversational booking application that was able to answer questions from the parents, interacting with the Bedrock agent to actually take action on their behalf. We use Lambda to execute the actions. Our data, minimal data, stored in DynamoDB, and it's dynamic data, so it's getting updated all the time with the latest appointments. And a foundation model is used under the hood for the kind of logical reasoning and to try and figure out the problem, try to figure out how to answer the question and how to provide a response. Now, you might be wondering, what does Miss White think of all this? She said it was good to have the queries handled by AI, so she didn't have all those messages to respond to, but she did suggest some improvements. Because the AI didn't understand that she needs a break, because she can't do back-to-back parents' appointments throughout the whole evening, so we need to go back to the drawing board and figure out, okay, how are we going to make the agent understand that she's going to need a 15-minute break, after working for maybe 90 minutes. So we need to go back. Maybe I could do that in the way that I actually instruct the agent to explain to it that she needs to have some break time to go and have a bio break or get a cup of tea or whatever. So that was my little demo for you. If you'd like to try this out for yourself, it will cost you around maybe $5 to $10, as long as you do remember to clean everything up at the end, especially the Jupyter Notebook, which you'll be charged for if it gets left running. And the QR code is for my tutorial, which tells you step by step how to do everything. And I think with this, one of the fun things of playing around with this is that it's really, really easy to change the use case completely. All you have to do is change the instructions, change the Lambda code, change the DynamoDB table data, or use a different database. And you can kind of use the shell of what's been created here to try and experiment with your own use cases that actually have meaning for you. And if you do try it, give me a shout, let me know how you got on with it. I had a lot of fun playing around with this, and it's not intended to be a serious application at all. It's just intended to be a way to kind of learn and find out how these agents work, what their limitations are. And I think it's a really good illustration of these agents are really dependent on what you give them. So what you give them in terms of data, what you give them in terms of actions, they're going to be limited by the capabilities and the data that you actually give them. Thank you so much. Grazie.
Thank you.
And rate this session.
So we have time just for a few questions, okay?
Thank you for the presentation, first of all. I just want to ask how the agent knows which function to call, not Lambda function, but function inside the Lambda function. I imagine that there is the LLM that extrapolate these from the context. So for if it's in this way, for each prompt, there are minimum 2 LLM calls, one for understanding which function to call and the other to elaborate the answer and give back the response. Is that correct?
I think that you could end up with multiple calls to the LLM if it's having to, if you give it a really complicated problem, and what if you gave it like multiple functionalities within the Lambda function as well? It might try things and discover that that didn't give me the answer and I'm going to try something else, or come back to you for clarification. I think that you could end up invoking your underlying LLM model multiple times, definitely. My understanding is that it's using that logical reasoning of the foundation model to actually look in its toolkit of, okay, what are the actions that I've got here? And it's looking at that first. It's not necessarily, I don't think it's looking at what's in the Lambda function. I think it's looking at what actions do I have here at my disposal that I can use to actually solve this problem.
Okay. And the parameters are also extrapolated under the hood from the prompt, the parameters that are passed to the Lambda function.
The parameters are, I think the way that this has been, the way that it's put together is that, the parameters are all separate. If you wanted to change, do you mean parameters like top P and that kind of thing? The
parameters of the Lambda function. The event, you have the code get parameters, and that parameters are extrapolated from the prompt and
yes,
under the hood.
Yep.